Hello, this is John Schaap and welcome to this video in the updated 2021 version of the AOS 8 video series. In this video I'm going to show you how to use IoT applications based either on Wi-Fi, BLE, ZigBee and third-party protocols by providing the connection layer using Aruba access points. ArubaOS supports IoT applications based on Wi-Fi, for example Wi-Fi tracking, BLE, for example asset tracking or sensor monitoring, ZigBee and third-party protocols over USB extension by providing the connection layer using Aruba access points. IoT devices can send or receive data over the built-in radios of Aruba access points or supported third-party radios connected over USB to the third-party servers. The network that is used in this video is the same as for other videos, except we now use the built-in BLE ZigBee radio to capture and send this data to an IoT server. In the video I show you how to use Meridian and IoT-Utilities as a server. Meridian is a fully Aruba supported solution, and for IoT-Utilities we are very thankful to Jens Flugel. IoT-Utilities is not an official Aruba product, but very helpful in demonstrating IoT. You will find the link to IoT-Utilities in the description below. It also has an excellent set of documentations included how everything works. An Aruba IoT radio is an additional internal or external radio in the Aruba 300 or 500 series access points that can be leveraged for IoT connectivity. A single Aruba 300 or 500 series AP can support up to 2 IoT radios, one internal and one external. For example, BLE on one radio and ZigBee on the other radio concurrently. The AP adds or removes the radio-specific headers from or to IoT devices, example BLE or ZigBee, and forwards or receives the data payload encapsulated in the Aruba IoT server interface protocol to and from the IoT third-party server. The internal radio can be found in Aruba 300, 500 and 600 series APs supporting the following radio technologies. 300 series access points is BLE 4 Gen 1. 500 and 600 series access points is BLE 5 or 802.15.4 Gen 2. Example is ZigBee. The internal and expansion BLE 5 IoT radio can be configured to run BLE and ZigBee concurrently. But in this configuration, the IoT radio can only transmit but not receive BLE packets, while the ZigBee communication works bidirectional. This allows enabling the AP's BLE console as well as BLE beaconing for indoor navigation use cases in parallel to ZigBee use cases. But BLE tracking use cases like asset tracking are not supported in this case. In order to support BLE tracking or bidirectional use cases concurrently to ZigBee on the same AP, the two IoT radios Gen 2, one internal and one external, are required. The external radio should be used as ZigBee radio in this case. Therefore, this scenario is currently only supported on the Aruba 5 and 600 series APs. For Meridian beacon management and Meridian asset tracking, you need to install these certificates when using AOS 8.9. You can download them from this webpage over here, and you will see the root CAs over there, and you need to download one specific one, the R1 one. Downloaded it in PEM format, and the other one that you need is this one, the D4. Also download that in PEM format, store it on your local computer, and then go to the mobility conductor, go to HPE configuration system and install the certificates. I already did it over here. You see one intermediate CA and one trusted CA. It's very simple. You just click the plus sign, give the certificate a name, browse for the file that you downloaded, upload it in PEM format and select the right type, either trusted CA or intermediate CA, depending on which one you are going to upload. You need to do a similar thing with IoT-Utilities. It also comes with a built-in self-signed certificate, and you need to install that also on your mobility controllers. Otherwise the connection to IoT-Utilities will not establish. So let's have a look how to configure all this on the mobility conductor. So we are logging in to the mobility conductor and we go to Manage Network HPE, configuration, and then you will see in the bottom the IoT tab. There's the IoT transport, IoT radios, ZigBee services, and ZigBee socket devices. So IoT radios, let's configure one. So you give it a name, the profile, and you say if it's for the internal or externally connected radio. And then you do the radio mode. That can be BLE, ZigBee, or BLE and ZigBee. And then the operational mode can be beaconing, scanning, or both. And you can enable or disable the BLE console. So that was the radio profile. We just configure one radio profile, and we are going to configure the AP group that we are going to use. So that's where our APs are in. There's also an IT tab there, and that's where you select the previously configured radio profile. So that's now being applied to the 3 access points in this group. Then we go back to IT, and we go to transport. Now we're going to configure the transport profile for Meridian. That's the first one. So we're going to do one for Meridian and one for IoT-Utilities later on. So give it a name, and then select the server type. That can either be Meridian Beacon Management, Meridian Asset Tracking, Telemetry HTTPS, Telemetry WebSocket, ASA Abloy, or Azure IoT Hub. We're going to do Meridian Beacon Management here. The method is based on token authentication. This is Meridian. You go to Beacons, Beacon Management. That's where you can find your BLE URL. Copy that and paste it in here. And the same for the access token. That can be found there. Copy it, go back, paste it in here. Proxy is not used. So we're going to select the AP group where the APs are in. So that's this AP group, and that is it. Nothing else is needed. So this should establish the connection to Meridian. Keep in mind that it can take a couple of minutes before you see it established. So you still see here transport context is no context waiting for data. So it's not established yet. After a couple of minutes, do the same thing, and you now see that it is ready and that it has updated Meridian. Go to Manage Network, the dashboard, and there's an IoT tab there, and you see one IoT transport stream, the one that we just configured, and you also see the number of beacons and other BLE devices that can be seen in my lab environment. So that's already a total of 74 devices and just one transported stream, of course, towards Meridian. So I'm going to go back to the CLI of the mobility controller. That's VMC01 in this case. And then we're going to have a look at all the commands that you can do over here. So show AP BLE database shows you the number of APs that terminate on this controller. Remember, it's controller cluster, so APs can show up everywhere. This cluster member has 2 APs, and you also see then 2 internal radios, of course. Show AP debug BLE config AP name and then the name of the AP. That's where you can see which IoT radio profile is attached to this access point. You also see the ZigBee profile that's not configured right now, and you see more info about the internal radio. And of course also the transport profile that's being used on this radio. So that's the Meridian Beacon Management transport profile that we just configured. So this gives you a good overview of exactly what is configured on the IoT radio in this particular access point. Next is show AP debug BLE counters AP name, name of the AP. That's where you see all the entries of the BLE devices that this access point hears. So this one hears a total of 35 and much more information about all these BLE devices, the signal strength, etc. Then we do show AP debug BLE table, AP name, AP name of the AP, and then all. and that's where you see the device table, but also the Aruba beacons and the generic beacons split out. So there's Aruba beacons that it can hear, but also other BLE devices in my lab environment. Show BLE relay report shows you the IoT transport profile and if it's connected, yes or no. And then show BLE relay transport context shows you the same IoT transport profile. And if you have multiples configured that we see in the next part of the video, you'll see them all listed here. So we go back to the graphical user interface and to Meridian, and you can see that it is connected also from that side, because you see here that it receives data from the controllers a couple of seconds ago. So that's all working fine. Next is going to configure IoT utilities. So that's a new transport profile. In this case, we're going to use telemetry web sockets. And then the same thing, it's token based. And you need to copy the server URL from the Android device. So in this case, that is my Android is living on 192.168.5.2.110, and I also need an access token which I copy. From there, client ID is just to identify which device is sending the data to IoT utilities. Same thing with AP groups. So it's in the same AP group. But what I'm going to select here right now is I want to send BLE telemetry data, BLE data, and also Wi-Fi data. So these three things are going to be sent to IoT utilities. So now you see that we have two different transport profile, and they both utilize the single radio profile that we have configured. Because you can only attach one radio profile to an AP, and you can attach up to 4 transport profiles to an AP group or AP. So now you see that there's two transport streams, IoT utilities and the Meridian one configured previously. And if you now do show BLE relay IoT profile, you see the Meridian one that we saw before. But if you then go further, you see the next one is IoT utilities on that web socket server URL. And you also see that the connection is established there. And if you do transport context, you now see index 0 is Meridian and index 1 is the telemetry WebSocket, and they are both active right now. So you can have, as I said before, multiple IoT transport profiles. If you do BLE relay report, you see IoT utilities and with more information about what it's doing with that connection. This is the IoT Utilities dashboard running on an Android tablet, and you see that it hears 4 sensors, 4 sessions, and that it receives BLE telemetry, BLE data, and Wi-Fi telemetry information. If you go to the sessions, you will see that there is 3 VMCs, where we have 3 virtual mobility controllers, 31, 32, 33, all sending data to IoT utilities. And these are the APs that are being used. If you go to sensors, that's the certificate that I talked about in the beginning of the video that you need to download and install on your mobility controller. And this is where you get your telemetry URL, your dashboard URL, your authentication URL, and also the token that is needed to establish the connection. If you then go to BLE telemetry, you see all the information that has come in. BLE data is the BLE data information that has come in. You can click it and get more details about who is sending that information. And the same goes for Wi-Fi data. These are all associated and unassociated clients that can be heard by the access points. If you go to System Profiles, All Profiles, you will see this BR_IoT, where you can also configure your IoT profiles. But I recommend you to stay away from here, because as you can see, if you try to change something in here, it comes back to you with a screen with all kinds of red things. So let me try that. So I'm going to change the client ID here and then save it. And you'll see that it needs values for all the other items that you see on the screen. From iOS 8, 9 and upwards, I recommend you to just go to Configuration IoT and configure everything there. Or use the command line interface, of course, because in the command line interface you can configure everything also. If you do show IoT profiles, you'll see the number of radio profiles that are configured. You can see the content of the radio profile. And the same goes for the transport profile. You do show IoT transport profile. You see that we have configured 2 transport profiles. And if you then do it the same command, but then with the name of the transport profile, you can see exactly what has been configured over there and what other parameters are available in the command line interface. Let's have a look at the last one. That's the Meridian one. So you see all the details there. You see the URL, the token, the server type, etc., etc. That brings us to the end of this video, so let's recap what we have done. In the middle you see the Wi-Fi infrastructure, so the mobility controllers and access points, and there you configure your IoT radio profile and your IoT transport profile. The radio profile is to configure either the internal radio in the access point or the external radio that you can connect on the USB port, as you can see in this picture. The transport profile then describes how you are going to connect from the Wi-Fi infrastructure to the third-party system. So that can be, as we have seen in the video, Meridian or IoT-Utilities or any other product. Specifically with the things that you see there on the left-hand side, Assa Abloy and Anocean, they have their own server where they need to connect to. So on the left-hand side you see all the possibilities. It's either BLE, Wi-Fi RTLS or ZigBee. Those are the protocols supported there, and that's then being sent to the third-party system. Third-party system in some cases also can talk to the devices on the other side, so to the IoT devices. So it's bi-directional communication. Please like, subscribe and let me know in the comments what you think. Bye for now.